speed maths, squares and square roots, cubes, cube roots, and powers. Let us now learn the shortcut tips and tricks to find squares in a faster way. We know that the square of a number x is nothing but the number x multiplied by itself. It is very important that we find out the square of the given numbers very quickly to avoid wastage time in the exam. So, in this part of the discussion, we should see tricks for finding squares of the given numbers quickly. Here is a list of 1 to 30 squares is presented. So, remember all these values perfectly. You should not even with a single second for gaining these squares. It is observed from the table how the unit place of the square changes as the used space of the number changes. So, it is important to find the square roots. For example, whenever a number ends with 1, the square root ends with either 1 or 9. You see that in the numbers 121, 361, 441, and 841, their square roots end with either 1 or 9. Similarly, whenever a number ends with 4, the square root ends with either 2 or 8. You see that in the numbers 144, 324, 484, and 784, their square roots end with either 2 or 8. Whenever a number ends with 9, the square root ends with either 3 or 7. You see that in the numbers 169, 289, 529, and 729, their square roots end with either 3 or 7. Whenever a number ends with 6, the square root ends with either 4 or 6. You see that in the numbers 196, 256, 576, and 676, their square roots end with either 4 or 6. Whenever a number ends with 5, the square root also ends with 5. In other words, the square of the number ending with 5, then the number is called a complementary number. For example, 15 square is 15 into 15, which is 225. Please refer to multiplication tricks for complementary numbers. Tricks for squares. For 30 to 80, consider the base value as 50. For 80 to 130, consider the base value as 100. Let's look at some examples to understand this concept. Find 63 square. Let's consider the base value is 50. Split the number 63 into 50 plus 13. Then 63 square becomes 50 plus 13 whole square. We know that a plus b whole square equals to a square plus 2ab plus b square. A square is 50 square, which is 2500. 2ab is 2 into 50 into 13, which is 1300. b square is 13 square, which is 169. Combine these values, 2500 plus 1300 plus 169. As a result, 63 square is 3969. Let's look at a second example to understand this concept. Find 42 square. Let's consider the base value is 50. Split the number 42 into 50 minus 8. Then 42 square becomes 50 minus 8 whole square. A square is 50 square, which is 2500. 2ab is 2 into 50 into 8, which is 800. b square is 8 square, which is 64. Combine these values, 2500 minus 800 plus 64. As a result, 42 square is 1764. Let's take a third example to understand this concept. Find 108 square. Let's consider the base value is 100. Split the number 108 into 100 plus 8. Then 108 square becomes 100 plus 8 whole square. A square is 100 square, which is 10,000. 2ab is 2 into 100 into 8, which is 1600. b square is 8 square, which is 64. Combine these values, 10,000 plus 1600 plus 64. As a result, 108 square is 11,664. Let's look at another example to understand this concept. Find 84 square. Let's consider the base value is 100. Split the number 84 into 100 minus 16. Then 84 square becomes 100 minus 16 whole square. A square is 100 square, which is 10,000. 2ab is 2 into 100 into 16, which is 3,200. b square is 16 square, which is 256. Combine these values, 10,000 minus 3,200 plus 256. As a result, 84 square is 7,056. Let's see how many of you can solve these 6 questions and get all 6 of them correct. Answers for the given 6 questions. I hope all of you have got all 6 of them correct. Practice well on these. Let us now learn the shortcut tips and tricks to find square root in a faster way. As I mentioned, whenever a number ends with 1, the square root ends with either 1 or 9. Similarly, the pattern to be followed for the unit space. If a number ends with 4, the square root ends with either 2 or 8. If a number ends with 9, the square root ends with either 3 or 7. If a number ends with 6, the square root ends with either 4 or 6. If a number ends with 5, the square root also ends with 5. Let's look at some examples to understand the square root concept. Find the square root of 6084. The units place of the given number ending with 4. As we all very well know, when a number ends in 4, its square root ends with 2 or 8. The next step here is to leave the last 2 digits. The remaining number must be less than a perfect square. The remaining number in this case is 60. If we take 8 squares is 64, which is more than 60. So, we take 7 squares is 49, which is less than 60. So, the second part of the answer is 7. The answer may be 72 or 78. As we all know, 70 square equals 4,980 square equals 6,400. Here, the number 6,084 is closer to 6,400. If 6,084 is closer to 6,400, its square root is also closer to 80. Therefore, the square root of 6,084 is 78. Let's look at another example to understand the square root concept. Find the square root of 12,769. The units place of the given number ending with 9. As we all very well know, when a number ends in 9, its square root ends with 3 or 7. The next step here is to leave the last 2 digits. The remaining number must be less than a perfect square. The remaining number in this case is 127. If we take 12 squares is 144, which is more than 127. So, we take 11 square is 121, which is less than 127. So, the second part of the answer is 11. The answer may be 113 or 117. As we all know, 110 square equals 12,100 and 120 square equals 14,400. Here, the number 12,769 is closer to 12,100. If 12,769 is closer to 12,100, its square root is also closer to 113. Therefore, the square root of 12,769 is 113. Let's see how many of you can solve these 4 questions and get all 4 of them correct. Answers for the given 4 questions. I hope all of you have got all 4 of them correct. Practice well on these. Let us now learn the shortcut tricks to find approximate square roots in a smarter way. If the given integer in the square root is not a perfect square, then use a formula that is a plus or minus d divided by 2 into a, where a is the square root of a perfect square number. D is the difference between a given integer value to a perfect square number. In this case, the perfect square value is the nearest value of the given number. Let's look at an example to understand the approximate square root concept. Determine the square root of 6,000. You know that the integer 6,000 is not a perfect square. As we all know, 80 squared equals 6,400, which is the nearest value of 6,000. We will say a is 80. D is the difference between 6,400 and 6,000 is 400. We are looking at the integer 6,400, which is more than 6,000. The square root of 6,400 is 80. So, we must reduce the difference value from 80. That is, 80 minus 400 divided by 2 into 80. Then, 80 minus 10 by 4. The fraction 10 by 4 equals 2.5. As a result, 80 minus 2.5 is 77.5, which is an approximate answer. Instead of the integer 6,400, let us consider 4,900. As we all know, 70 squared equals 4,900, which is the nearest value of 6,000. We will say a is 70. D is the difference between 6,400 and 4,900 is 1,500. We are looking at the integer 4,900, which is less than 6,000. The square root of 4,900 is 70. So, we must increase the difference value from 70. That is, 70 plus 1,100 divided by 2 into 70. Then, 70 plus 110 by 14. The fraction 110 by 14 equals 7.8. As a result, 70 plus 7.8 is 77.8, which is an approximate result. Let us now learn the shortcut tricks to find cubes in a regular procedure. Here, the list shows the integers and their cube values. Whenever a number ends with 1, the cube root ends with 1. Similarly, the pattern to be followed for the unit space. Here, you notice that if a number ends with 4, 5, 6, 9, the cube root also ends with 4, 5, 6, 9, respectively. However, if a number ends with 2, the cube root ends with 8. Likewise, if a number ends with 8, the cube root ends with 2. Then, 2 and 8 are interchangeable. If a number ends with 3, the cube root ends with 7. Likewise, if a number ends with 7, the cube root ends with 3. Then, 3 and 7 are interchangeable. A plus or minus b whole square is easy for finding the square of the numbers. However, a plus or minus b cube is a little complicated. Compared to a plus b whole 3 formula or ratio method, it is very easy to follow the regular method, that is, x cube can be x square into x. Let's look at an example to understand the cube concept. What is the 24 cube? 24 cube can be written as 24 square into 24. We already know that 24 square is 576. 24 cube can be taken as 576 into 24. As we have covered in Speed Maths 1, the product of the 3-digit number and a 2-digit number, 576 into 24 is 13,824. Then the answer for 24 cube is 1, 3, 8, 2, 4. Let's look at another example to understand the cube concept. What is the 32 cube? 32 cube can be written as 32 square into 32. We already know that 32 square is 1024. 32 cube can be taken as 1024 into 32. Then, 1024 into 32 is 32,768. Then the answer for 32 cube is 32,768. 67 cube can be written as 67 square into 67. We already know that 67 square is 4,489. 67 cube can be taken as 4,489 into 67. Then, 4,489 into 67 is 300,763. Then the answer for 67 cube is 300,763. Let us now learn an important shortcut trick to find a cube root in a smarter way. Here, the list shows the integers and their cube root values. Whenever a number ends with 1, the cube root ends with 1. Similarly, the pattern to be followed for the unit space. Here, you notice that if a number ends with 4, 5, 6, 9, the cube root also ends with 4, 5, 6, 9 respectively. However, if a number ends with 2, the cube root ends with 8. Likewise, if a number ends with 8, the cube root ends with 2. Then, 2 and 8 are interchangeable. If a number ends with 3, the cube root ends with 7. Likewise, if a number ends with 7, the cube root ends with 3. Then, 3 and 7 are interchangeable. Let's look at some examples to understand the cube root concept. Find the cube root of 551,368. The units place of the given number ending with 8. As we all very well know, when a number ends in 8, its cube root ends with 8. The next step here is to leave the last 3 digits. The remaining number must not necessarily perfect cube, but the cube should be less than the remaining part of the given integer. The remaining number in this case is 551. If we take 8, 8 cube is 512, which is less than 551. Therefore, the cube root of 551,368 is 82. Let's look at another example to understand the cube root concept. Find the cube root of 50,653. The units place of the given number ending with 3. As we all very well know, when a number ends in 3, its cube root ends with 7. The next step here is to leave the last 3 digits. The remaining number must not necessarily perfect cube, but the cube should be less than the remaining part of the given integer. The remaining number in this case is 50. If we take 3, 8 cube is 27, which is less than 50. Therefore, the cube root of 50,653 is 27. Let's see how. Many of you can solve these 4 questions and get all 4 of them correct. Answers for the given 4 questions. I hope all of you have got all 4 of them correct. Practice well on these. Let us now learn an important shortcut trick to find powers in a smarter way. Let us consider the important power formulas. A power m into a power n. We notice that the base values are equal. Then the powers should be added, that is, a power m plus n. Similarly, a power m divided by a power n is a power m minus n. A power m whole power n is a power m into n. If the powers are equal, then the bases should be multiplied by each other. That is, a power m into b power m is equal to a into b whole power m. Similarly, a power m by b power m is a divided by b whole power m. A power minus m equals 1 divided by a power m. M root a is a power 1 by m. M root of a power n is a power n by m. A power 0 is 1. Let's look at some examples to understand the power concept. Solve 2 power 0.2 into 64 into 8 power 1.3 into 4 power 0.2 is equal to 8. Power question mark. Let us find the value of the power of 8. Let us consider the left part of the equation. It is noticed that the powers of 2 and 4 are same, that is 0.2. If the powers are equal, then multiply the respective bases. 2 power 0.2 into 4 power 0.2 is 8 power 0.2. Let us convert all bases into common bases, which is 8. Then, the equation becomes 8 power 0.2 into 8 power 2 into 8 power 1.3 is nothing but 8 power 3.5. It is observed that the bases are the same, that is 8. If the bases are equal, then add the respective powers. 0.2 plus 2 plus 1.3 is 3.5. That is 8 power 3.5. Comparing left-hand side values with right-hand side value, that is 8 power 3.5 equal to 8 power x. So x is equal to 3.5. Let's look at another important example to understand the power concept. Solve 9 power minus 7 divided by 27 power minus 6 whole power 3 by 4. We know that a power minus m equals 1 divided by a power m. Applying the inversion principle, we get 27 power 6 divided by 9 power 7 whole power 3 by 4. Now, we convert common bases for the numerator and denominator values. To do this, 27 can be written as 9 power 3. Then the numerator value becomes 9 power 6 plus 3, which is 9 power 9. It is noticed that numerator and denominator values share the same base, which is 9. If bases are common in the division, then subtract the powers. As a result, 9 power 9 by 9 power 7 becomes 9 power 2. So the fraction becomes 9 square whole power 3 by 4. We can write 9 square as 3 power 4. Using the formula a power m whole power n is a power m into n. Then 3 power 4 into 3 by 4 is 3 power 3. Then the final result is 27. Thank you. Subscribe to this channel and press the bell icon to get regular updates from our channel.